So welcome to this. This is the FMSP online revision session for AQA Statistics 2. And in this session we're going to look at chi-square testing. So what do we need to be able to do? Now, you've got to be careful with this because if you read other textbooks, they do more with this. They do something called goodness of fit as well. So make sure that for AQA Statistics 2, you only need to worry about contingency tables. Okay, so you need to be able to understand and use chi-squared in a contingency table setup, which is similar to what you would have done in things like biology, if you do biology, of course. You need to understand when an approximation is valid. We'll explain that as we go along. And also, this is very important for AQA, you need to be able to use Yates's correction when it's given, when it's required to be used. Okay, we use it when we're dealing with 2 by 2 tables because chi-squared's a funny little creature and it's not that effective with small contingency tables. So this guy called Yates came up with a method which improves the reliability, I guess, of the chi-squared statistic. So it's just one of those fixes that we do to make it more reliable. So this is all you're given: goodness of fit tests and contingency tables. So as I was saying, we don't need to do that on S2. So really, you need to be aware that we're going to do it for contingency tables. It is true for goodness of fit, but we don't need to worry about it. There is another way of calculating this, but to be honest, for AQA, just because of how the questions are written, it's best to stick with this one. Okay, so June 2011, question 3. Emily believes that the performance of 16-year-old students in the GCSEs are associated with the schools they attend. To investigate her belief, Emily collects data, and this is our data below. She's got collected data, so her observed data, but also she's calculated something called her expected data, and you need to be aware that there are 12 pieces of expected data. So if we count how many pieces of expected data there are 12. That's important. Okay, this tells me that I don't need to consider corrections. So it's not a 2 by 2 table, basically. It's a 4 by 3 table. Okay, so we don't need to worry about Yates, which is great news. Great, so we're asked to state a null hypothesis that Emily can use. Okay, she's going to do a test. So there's 2 ways of phrasing this. Now this is non-parametric, so we need words. So null for no, so no association. Now please don't just write no association. That's going to get you not very many marks. You need it in context. So it's no association. Well, it is interesting. Sometimes you are given this, but sometimes you're not. So it's always best to fully apply. So no association between type of school and performance at GCSE. So performance of 16-year-olds in GCSE. Now, there's another way of phrasing this. Instead of talking about no association, we could talk about them being independent. Okay, so that would be appropriate as well. And then we're asked to work out the value of the test statistic. So the test statistic is the sum of O minus E all squared over E. Okay, and how is this marked? Well, basically you get some marks just for trying stuff. So there are 12 things you need to do. I'm not going to write them all down here, I'm just going to write the sum. But if you get greater than or equal to 4 correct, you're going to get your first method mark. If you get greater than or equal to 8 correct, you get your second mark. And then if you actually get all of your chi-squareds added together correctly, 12.019, you are going to get your final accuracy mark. Okay, and there is a bit of tolerance on this. We will accept anything between 8.9 up to 12.1. Okay, so there's a bit of flexibility. So you can still get the accuracy mark by getting 1 or 2 of these calculations not quite right, which I think is quite good. Okay, so again, I'm not going to write them all out because I trust you can subtract, square and divide. So now we've got to conclude the hypothesis test. So how does this work? Well, we need to work out the degrees of freedom. So the degrees of freedom for a test like this are rows minus 1 times by columns minus 1. So this is going to be 4 minus 1 times by 3 minus 1, which is equal to 6. So we know we're going to be dealing with 6 degrees of freedom. Okay, we then need to choose the correct percentage. So what are we looking at? We were told that we're going to do this with 6 degrees of freedom at a 1% test. Okay, so what does that correspond to? Well, you need to choose the correct chi-squared statistic. Okay, and we are always looking at this half, not this half. Okay, so we're going to be looking here. The reason is chi-squared is a one-tail test really, and we're just looking at the top end tail. Okay, so that's going to give me a test statistic of 16.812. And what we can see is the following piece of information. Okay, my chi-squared 6 at 1% is greater than my test statistic. So my critical value is greater than my test statistic. If this happens, what we can do is there's insufficient evidence to reject H0. So what we can say is there's no association between, and again, just rephrase your hypothesis again. So how are our marks allocated here? Well, you get B1 for getting the correct degrees of freedom, you get B1 for getting the correct test statistic, critical value, sorry, and then you get an A1, and I'll talk about the A1 in a minute, you get an A1 for a correct conclusion. However, this has to be correct based on what you've done previously. So if you haven't worked out your test statistic correctly and you've got no marks, you're not going to get this mark either. Okay, so just be very, very aware of that. It's to prevent you getting marks from just kind of guessing, really. Okay, so we're then asked to make one comment on the GCSE performances attending Bailey Language College. Okay, so we've made we've made a conclusion that there's no association. Okay, just bear that in mind. So one way of phrasing this is actually it'd be bad to start looking at individual schools because we've just said that there isn't an association. Okay, so not suitable to look individually. Now you can, and if you do, you're not going to get penalised. So if we look at Bailey Language School's results, okay, there are more than expected gained at least more than 5 GCSEs. Okay, if we look at here, it's just comparing data now, isn't it? 265, 248. That's quite a big jump. Okay, so more than expected gained at least 5 GCSEs, or fewer got no GCSEs. It's really just looking at the table. It's only worth 1 mark, so we're not looking at this in massive detail, but that's the kind of thing that we'll be looking for here. Personally, I'd go for this one, but there's lots of different ways of answering these. So E, Emily's friend Johanna uses the same data to do a 10% level. State the justification that she should reach. So here, basically it's the same idea, except we're now using a 10% test statistic and critical value. So 10% would lead me at 10.645. So actually what Johanna will do is she would reject H0. So there is association. Okay, so that's how it would be different. Okay, between, and again you must fully contextualize, so between type of school and GCSE performance. Now if you look at the mark schemes for these, you'll find some things are in bold, you need them, some things in brackets, you don't. My advice is just write everything. Okay, don't look at a mark scheme and say, oh, I don't need to write that bit, I don't need to write that bit. Write everything, because again then it's always going to be entirely correct. Okay, so moving on to June 2010 question 2. So it's claimed that a new drug is effective in the prevention of sickness in holidaymakers. We've got a sample of 100 taken, and we've got this table. Now instantly alarm bells should be raised because it is a 2x2 table. So we must be looking at Yates' correction. So I like this question because it's a full process. Okay, assuming the holidaymakers, we've got to do this. So we've got to work out our expected values. We've got to work out everything. Okay, so clean page time. So your expected values, how do we work those out? Okay, so for each expected value, you take the row total the column total, and you divide it by the grand total. Okay, so for the first cell, E11, that's going to give me 80 times by 35 over 100. Okay, and we do that for each one. So I'm going to put the numbers in here. So that's going to be 28. Now, that's actually all I need to work out. If you think about it, the rest follow. So 28, that must therefore be 52. Okay, this one down here must be 7, and this one here therefore must be 13. Okay, so just bear that in mind. Okay, so test statistic time. How do we work this out? Well, to use Yates's correction, your x squared statistic must now be the sum, and you've got to learn this. It must be the sum of the modulus of O minus E minus a half, and it's that we're squaring over E. Okay, so it's a good idea, I think, to rewrite this as a separate table. So OE, O minus E modulus minus a half, and then your chi-squared in each one. Okay, so we're going to have 24, 28, that's now going to be 3.5, and then what we can do here is 3.5 squared divided by 28, okay, 0.4375. So it's good to do this for each one, but what you'll notice is all of these tend to be 3.5, just because of the nature of how these work. So 56, 52, 11, 7, 9, 13, and your other values are 0.2356, 1.75, and 0.9423. So what we have is we have your test statistic chi-squared being 3.3654. Okay, so let's write that down again. So your test statistic was 3.3654. Now, so what I now also need to consider is my hypotheses. So H0, there is no association, or they are independent, whichever way, no association between, I prefer no association because it ties nicer with biology and psychology, I think. So between drug and prevention of sickness. Also, don't forget you need an alternate hypothesis, so there is an association. Now please do not use dittos. Write it out in full. Okay? Now again, if you look at mark schemes, they may suggest that you only need one of them. Well, no, you need both of them, but only one of them needs to be fully correct. But again, don't take chances in the exam. So they're my hypotheses. So what else do I need? Okay, yes, I need my chi-squared statistic. So how many degrees of freedom do I have? Well, 1. Okay, that's all you have, 2 by 2. So it's R minus 1, column minus 1. That's your new, so that's 1. Okay, and what are we doing? Well, we're looking at this at the 5% level. Okay, so chi-squared with 1 degree of freedom at the 5% level is going to lead me to 3.841. So, great, what can we conclude? Well, because your test statistic is smaller than your critical value, what we can do is we actually accept, as we've said before, we accept H0. Okay, so there is no evidence to support that the drug is effective, or words to this effect, effective against sickness. Okay, so let's have a look at how this is marked. Let's get the, change my colour so we can see. Okay, so let's just go back a slide. So you're going to get 4 marks in total for getting to this value. Okay, you get M1 for working out some expected values. You get M1 for working out and using Yates's correction. Okay, you get M1 for then attempting the next column, and then A1 for the final one. Okay, so Yates is important because you're going to get at most 2 marks if you don't use it. Okay, and then here, what do we get? Well, you get a B mark for your hypotheses. You get a B mark for choosing the correct statistic, in this case, the correct critical value. You get an A mark for accepting or not rejecting H0, and then you get an E mark for suggesting your evidence. Now, again, if you made some mistakes earlier, which meant this was the other way around, and you did actually end up rejecting H0, as long as it was correct, you would get this final mark, which is quite nice. Okay, so in fact, actually, if you got your chi-squared value wrong here, you would still get the A1. So that was a follow-through, and this is a follow-through as well. Okay, so 2 by 2, please make sure you deal with Yates' correction, and then everything will be absolutely fine.